So, hi guys. I was invited to come and speak today about what we're doing with regards to innovation in Europe, specifically the industrial biotechnology sector, which is where I live. But first of all, I'd like to thank Dr. Lalo for inviting me to come today, and the board and directors from CSIR. It's my first trip to South Africa, and unfortunately I brought the weather from the UK with me, so that's something that I'll have to live with for the duration. There is a large video in the middle of this presentation, which might be what's causing all the chaos with the computer, so I apologise, but we'll see if it works. So, I've been in the biotech sector in the UK. I'm a chemical engineer, I'm not a microbiologist, I'm not a fermentation scientist. I started my career designing chemical plants. For the last 10-12 years I've been working in SMEs within the biotech sector, biofuels, biochemicals, and then converting waste into biochemicals, and then latterly working at CPI, where my job is to take all of my previous experiences and leverage that to help academics and small companies get their technology through to commercialisation. And everything Kris just said is directly applicable to Europe and the UK. All of the points you talked about there about learning, it takes longer, you need more business acumen and commercialisation, that is all directly applicable, and I've got first-hand experience that says those slides and those points are correct. They're correct in South Africa, they're correct in Europe, and I know from experience that I was in Canada a couple of months ago, they're talking about exactly those points in North America in the same commercialisation kind of objectives. So I suppose what I'm saying is, I'm really pleased that we seem to be learning and having the same experiences around the world. I'm not so happy that we seem to be not learning from each other, and that we're all going through the same pains, when in reality, how much faster could we do things if we actually work together to overcome all of these things a lot faster and not have to learn everything firsthand ourselves. That wasn't in the presentation, so I've wasted my first 2 or 3 minutes. So CPI is a bit like CSIR, but not as big. We have 4 business units within CPI: printable electronics, biologics, industrial biotechnology, and formulations. And they're all kind of separate technologies. But in 2 slides' time, you'll see how they all overlap and they all come together. So we're distributed about a region in the northeast of the UK. Funnily, because we've got 4 business units, each of the business units focuses on specific technologies in their particular area. As I mentioned to you, I'm here to talk about industrial biotechnology. But we all do the same thing with regards taking companies or taking technologies or taking ideas from very low TRLs. Are you all familiar with technology readiness levels? Is that a term that's used here in South Africa? So we take ideas from relatively low TRL, and we take them through the TRL stages with the customers that we work with. The services within my business, we kind of help in many aspects. My team is a team of 65. I've got chemical engineers, I've got project managers, I've got fermentation scientists, I've got molecular biologists, I've got commercially savvy people, I've got guys that can do techno-economics. I can do a wide range of services. And that is what most people don't understand that they require. And again, reflecting back on what Kris said about business and commercial, it's not about the widget that you've invented, because that widget tends to be one part of a much wider supply chain or a much longer supply chain that requires a much broader set of skills and knowledge than you or your friends have probably got in developing that widget. So if it's a bug for fermentation, fantastic. What about your feedstock? How do you recover that product? Where does that product go into in terms of application? It is one part of either a series of unit operations or a series of products within the supply chain. So you need lots of different skills to actually help you get that product from TRL 2.3 through to market. All of the businesses within CPI focus on all of those markets, and in many of those markets we're actually in 2 or 3 different business units overlapping, and we're trying to increase more and more where our business units work together, because it is very easy to become siloed, and I'd be very curious to learn how you overcome that in CSIR with regards to the different technology spreads. But it is very clear. So when we have global players like BASF or Croda or Axo Nobel, who are large multinational companies that have got a broad spectrum of products that are actually interacting with multiple of our business units. How we pull them together and actually demonstrate the true value of CPI by it being able to leverage all of our experience and knowledge to support our customer is critical in each one of these business units. And that's taking us outside of IB into the biologic space or the formulation space. So the active that we produce in IB then gets made into part of the formulation before it actually goes anywhere near the BASF product or the actual paint or whatever it might go into. So what I'm telling you, or what I'm sort of trying to emphasise is the collaborative nature, the collaborations within companies, collaborations outside of companies, and collaborations throughout industry to actually help get a product or a technology from, hey, I've got an idea, through to, hey, I've got a product that's actually producing a positive flow on my balance sheet. Because in the end, having the idea is nothing. Getting the positive flow on your balance sheet, that's the measure of success. Writing a few papers or even getting a patent on something, unless you're academic, isn't actually really beneficial, because the impact it has on society is actually quite minimal. The impact on society comes when you establish a manufacturing plant and you create jobs and you create training, and then you give your supply chain and logistics companies that work in the area jobs because they've got to provide material to you, and so on and so forth. So one of the big things that's coming through now in the UK, where they've invested billions over the years, is what is the actual impact? Don't care about the technology anymore. Take that for granted. We've got the best academics in the world, we've got some of the best industry in the world. But unless you're converting that into product and into a market impact, you might as well not be doing it. Alright, so with that all in mind, back in the middle of the noughties, the UK recognised that it was actually having a challenge in doing this translation, in the translation space, going from academic ideas through to industry. And it was because of companies like ICI were divesting themselves out of existence. UK didn't have these big bellwethers of industry anymore. We sort of like had satellites for BASF and US-based companies and other European-based companies or Asian-based companies. So they developed a thing called the Catapult Network, which probably is a little bit bigger than CSIR, but has very similar in terms of technology strands, because the Catapult Network does everything from synthetic biology through to satellite applications. And there's about 13 centres around the UK where they've invested tens of billions of rand over the last 10 years to actually enable, using public funding, put infrastructure in place to allow industry to access that infrastructure, SMEs and academics to access that infrastructure to overcome what's called the valley of death. And I'll talk a little bit about that in a minute with the TRLs. So CPI, long story, CPI is part of one of these catapults, and we're part of the high value manufacturing catapult, which looks at materials, chemicals, process industries, industrial biotechnology, healthcare, healthcare production. Talk about TRLs 1 to 9. We all know TRL 1, 2, 3, academic. That's where your idea, that's where you've got an idea, that's where you've written a couple of papers, that's where it's in your test tubes. You've done it once or twice, a couple of times maybe in the laboratory. TRLs 7, 8, 9. 7's your demo plant, it's not commercial yet. 8 is it's your commercial plant, but you've only done one. 9 is I'm actually on my 3rd commercial plant and we've got a proven history in a large market sector. And the bit in between is called the valley of death. So is everyone familiar with that terminology? Valley of death? Yeah, so again, consistent technology, terminology around the world. Well, CPI sits in 3 to 7, which is where I'm guessing CSIR sits. It's a space that the UK identified. Actually, without these companies to pull technologies through and promote, we have to put the infrastructure in, because if we don't have the infrastructure, we're not going to have a manufacturing industry tomorrow. So the CPI process is dead straightforward. We've got some assets, we've got some people, we've got some knowledge, we've got some skills. We're here to help you. We'll help you access public money, and we'll help you access private money. But we are here to help you by providing you with the skills and resources that you can't afford or you don't have time to actually access to get your product to market or your technology to market. We can help you with demonstration, and we can help you with de-risking. That's what we do. We reduce your risk, we help you prove your concept, and we decrease your time to market. Because I've heard a story from BASF. BASF, big German company, multinational, millions of people, millions of staff, billions of income. They did a technology process to produce nitrile, doesn't matter, a precursor, a biological precursor, where they had a really nasty petrochemical process that used high temperature, high pressure, really toxic chemicals. It still took BASF 12 years to produce that same, or replicate that same process with biotechnology. And they didn't have to go funding round every 6 or 12 months. They already had all of the staff. They already had the captive market. It's an intermediate for them, it just goes downstream. They already had the environmental drivers where they had operational sites. But it still took them 12 years to develop and commercialise that biotechnology process. It would be a really more effective example if I could remember the chemical name. So a little bit more about IB before I give you an example of what IB does and our assets. This is a little video that we made. We tried to get Tom Cruise, but he said he couldn't compete with the talent that we had in CPI. So if I can not mess this up completely, which I appear to be doing.
Industrial biotechnology, it's everything from the drinks that we might drink on a weekend through to the drugs we might take if we're in hospital. It's the fuel that goes in our cars, the clothes that we wear, it surrounds us in everyday life. The purpose of CPI's Industrial Biotechnology and Biorefining platform is to support both SMEs, medium and large style companies and academics to take their technology, to take their ideas and support them through the conception through to actual demonstration in a way that provides some scientific rigour or provides facilities that they wouldn't otherwise have. Within IB we have a wide range of analytical capability that's specific to industrial biotechnology. CPI is a key bridge between UK academia and UK industry. Industry speaks different languages to academics, and companies like CPI sit in the middle as a translator. And we can translate the academic into a commercial, we can translate the commercial into the academic. And by sitting in that bridging role, we get the best of both worlds and the ability to influence all. The IB team within CPI is a combination of scientists, engineers, project managers and technologists who have the ability to either take a process that's already running at commercial scale and take it down to a very small lab scale process, or we can take a very small scale process that's come from academia or a small medium enterprise, an SME, and actually take that company through scaling that process up in a rigorous and a risk-averse way so that they get the information that they require to enable them to go to the market, to raise funds, to enable them to move their business forward. Fundamentally, as we move forward, industrial biotechnology will start to replace more and more of what the chemical industry does for us. CPI's sweet spot, specifically industrial biotechnology's sweet spot, is between TRLs 3 and 7, where we take an idea that is already proven at concept. Someone can already do it somewhere in a test tube, and they may have done it a few times, but not robustly and repeatedly. And we can take that through to a pre-commercial demonstration with the facilities that we have here at CPI.
So I like that video because it does in about 3 minutes what I couldn't stand up here and waffle on about in 20 minutes, and it kind of achieves the same thing. We've already talked about the services that CPI does. Well, funnily enough, IBB does exactly the same services. From our facilities, we've had, let me do a conversion, £500 million worth of investment in terms of our assets and our facilities at the current sort of exchange rate. I've got a scale factor in my direct control of 10 to the 7, so 10 million. I can take your industrial biotechnology process through a scale factor of 10 million. That's a 1 mil experiment through high throughput screening where you get yes or no style answers to a fully integrated 10 cubic meter demonstration facility. Beyond that 10 cubic meter facility, you go into your TRL8 plant, depending upon what your process is, or in many instances that is actually production size, and we produce production samples and production quantities of material for clients. So there's a full operating team that works 24/7 behind that. But what we try to encourage our customers, and this is one of the challenges that any SME or any entrepreneur will face, you will get a pot of money, you will have a couple of data points, and you will run to scale, and you will try to get someone to do your experiment once or twice, prove your technology once or twice at scale, because that's what you believe you need to do to get your VCs on the hook a little bit more and progress it on further forward. I talk more people out of spending money on the large scale than I get new customers walking through the door asking for lab services, because I drive everyone to do everything repeatably, robustly, on scaled down models where we get absolute confidence that you can do the large scale things with a de-risked approach. And I would rather you spend £100,000 with me in the laboratory generating thousands of data points that tell everyone your process is assured and will work, than one or two dodgy data points at 10,000 litres where we're not quite sure because we've made a bunch of assumptions to get it in there. And I'll still want to charge you when I've run your process. If your process doesn't work, it's not my fault if you didn't provide me with the data. Generating the data and the assurity of the data is what the guys that have the money want confidence in being able to see. Because when the guys that design your plant, the first thing they ask for is the data that you're going to build the plant on, or base the plant on. If you haven't got that data, you say, well, we assume it's this and we assume it's that. It's like, yeah, you really don't want to be putting tens of millions of pounds of capital in the ground based on assumptions. Here's a case study. This is the biggest project we've got on our books, or I've got on my books at this moment in time. We've been doing it the last 2 years. This is a client from the US, so my two biggest clients are both US based right now. This is a client from the US who acquired a technology from Norway that had run at commercial scale previously. And what they bought was a bunch of records, a bunch of plant designs and whatever else. They've never ran the process themselves, and they were looking for somewhere to actually develop the process, demonstrate the process, generate quantities of samples that could be used to seed the market, so thinking commercially. And these guys had to produce tens of tons, or have to produce tens of tons of samples of material to get it into their market, to give them off-take agreements that they can then base their capital investments on. So it covered everything from very early stage technology development and understanding through to chemical engineering and plant design. Complex project, we broke it down into kind of 10 work, we call them work packages in the UK because it fits with the public funding structure. So if we call them work packages, then we know it fits with how we can get money out of the government as well sometimes. So we had 10 quite complicated work packages that had to be interwoven to deliver an outcome for the client. And the outcome for the client was a ton of material out the door by March this year. That was the objective. Quite clear. In October 2015, so 18 months prior to that, we started with a blank sheet of A4. So we went from blank sheet of A4, 18 months time, and about God knows how many thousands of man hours, to a ton of dry product ready to sample to customers. This is a quick overview of that process. So we did a three-way collaboration. Very quickly it occurred to me, yeah, we can design a plant, we can outline a plant. We're actually going to integrate their facility, their new bespoke bits of technology, into our existing hardware, because that way we'd save them a shed load of time, a shed load of capital. But recognising that we've got a lot of ideas, but my team aren't detailed engineers. They're not going to do all the wiring diagrams and the pressure drop calculations and whatever's necessary to actually build the facility. So we realised really quickly that we had to bring in an engineering company that could go from being a subcontractor at the very early stage, taking direction from us, to being the principal contractor when it came to construction, and carry the momentum through. And it's about that momentum and time to market. Multiple disciplines, we had everything from microbiologists through to electrical engineers and process operators. Complex multi-stream project that I've talked about, and it was around 100 million rand style capital investment for this SME company. Talk about project timeline. This is the point as well. The initial engagement with the customer was almost 15 months before we actually got to the blank sheet of paper. So just meeting them, from first meeting them to conversations to how are you doing, what's going on, how can we help you, these kinds of very light commercial conversations, through to, so what's going on in technology? Yeah, we're aware of this, we're aware of that. Could this help you? Could this, you know, are there ways we can work together? And it took 15 months to get them actually around the table to say, right, we've got a problem, give us a, you know, can you help us solve it? And then the journey was 18 months to getting the first ton of product out. Different stages of the project. This is just an example to show you the skills and disciplines that were involved in actually delivering the project, and why as an SME, when you're a team of 2 or 3 or even 10 people, it's practically impossible to do this thing on your own, because to do it properly, the breadth of scientific expertise, commercial expertise, engineering expertise, regulatory expertise that you require, it is difficult to accumulate and pay for on your salary bill within your company. And yet they are available externally, and you can contract them in, or consultants. But you want people with skin in the game. You want partners, you don't want contractors. And we were a partner with a customer on this, because out of it came a 5, 6, 7 year contract for us to continue working with them, which is underpinning our business moving forward. Technology transfer was really interesting. So gas fermentation is the big thing now in Europe. I'm not sure whether you're doing it here yet in South Africa, but gas fermentation, hydrogen, carbon dioxide, carbon monoxide, or methane style fermentations. Waste gases, waste industrial gases, or shale, or whatever it might be. We invested £1.25 million, so again, you know, 25, 30 million rand, in a state-of-the-art gas fermentation laboratory that went from 1 millilitre to 10 litres gas fermentation, fully gas enabled. Safety systems, flammability sensors, all of this kind of great stuff. Use that to attract the client. Absolutely fantastic. Once we learned what the client's process was, we had to completely modify one of our installations, because we'd set it up with state-of-the-art mass fermentation, mass flow control. The customer's process uses such small flow rates that what we'd installed didn't work. So there was a further investment and a further delay in building that facility. Now, the customer's actually doing their own as well. But if you think we did the tech transfer, it took us a few months to modify our vessel. What you can't actually see, I'll walk around here, because of all of this tubing and messing about, these are all the modifications that happened. That's the fermenter. The 10 litre. You can't see it. All the other stuff that we've had to put in the fume hood and in the cabinet where it sits. So quite bizarre, where you think you've got a state-of-the-art, world-scale or world-class facility, and it doesn't quite match your client's expectations. This was the facility. So again, I'll walk back around here. So CPI, this isn't all CPI, this is, ICI used to have a ICI, big global chemical company. This was its R&D, global R&D headquarters, and CPI has a number of facilities in here. Well, in this building here, I have what I call an IBF1, which is our scale facilities to 1 cubic metre. And over here, I have an IBF2, National Industrial Biotechnology Facility, 2, which goes up to 10 cubic metres as a fermentation volume. The client has used every possible piece of equipment in here, all our service provision, all of our vessels, and it actually uses a state-of-the-art 10 cubic metre fermenter as a sterile water hold tank at this moment in time. And the following pictures will show you what we did with the client. So that big bit of space that was at the side, you know, why is it the day after you start a construction activity it rains? So then you have to sort all the soil out, you start to build the different bits and pieces, and you build the, you know, even though we've got a facility, it took me about 3 months to convince the client. He still had to build his own control room, and there were bits of his process requirements that wouldn't fit into our existing facility. And then you can see the reactor structure. So one of the novelties about this process, you saw it was a CSIR gas fermenter that we were doing in the laboratory. Customer's reactor that we built is 75 metres of 10-inch pipe. So it's a horizontal gas reactor that is not agitated by anything mechanical, because you've got flammables in there, you've got methane and oxygen, so you were operating in a flammable zone. So the last thing you want is hot surfaces. All the control, all the bells and whistles, and then we ended up with a facility that we started commissioning in January, and we got the product out, the first product out, or the first ton of product out in March this year, and we've gone on and we've been operating pretty much continuously since then with a small turnaround for engineering improvements. Picking up on all of the last 10 minutes kind of chat, 20 minutes kind of chat, 25 minutes kind of chat, I have what I call a science of scale up and commercialisation. You cannot take a technology to market without these 15 factors. You cannot. I've tried. I ran my own SME for 5 years before joining CPI. CPI cannot do all of these, and we don't pretend to. But where we can't do it, we know someone that can. And that's the key. It comes into collaboration, it comes into working well together. It comes into providing that end-to-end service to your clients. And there's all sorts on there from feed. This is IB specific because it talks about feedstock and system biology and host design and all that kind of stuff. But this goes from your microbial feedstock through to your IP landscaping and your environmental footprint. And for many customers like Axo Nobel now, things like the greenhouse gas emission and carbon footprint of the product is actually critical to whether they'll support your technology. We're not alone in the UK. There are a number of open access facilities in the UK. However, the others tend to be aligned to universities. But rather than there being multiple different agendas running in the UK for what is quite a limited source of funding from the government, the risk is that you end up with having 2 or 3 people that have credibility in the sector telling different stories to government. Government then think, well, you one industry, you clearly don't know what you're asking for, so we're not going to give you anything. So we're actually consolidating ourselves into what we call the Biopilots UK Alliance, where there's 5 centres that actually are working closer together in a collaborative way to ensure that government delivers the funding that the bioeconomy needs to make the UK turn industrial biotechnology potential into industrial biotechnology impact. However, we're also doing it in Europe. So pretty much every country in Europe has a facility like CPI. Germany has Fraunhofer, Belgium has Biobase Europe, there's bioprocessing facilities in Holland, there's the ARD in France, and we're all working together in a project called Smart Pilots, which is across Europe, where we're trying to understand the funding landscape for both our customers and assets to ensure that different regions in Europe don't just keep building shiny steel without actually thinking about the costs associated with running it and the customers and products that are necessary to deliver sustainability for those business models. So that's what we're doing in Europe. That was an example of what we're doing in the UK. Thank you very much.